So I'm going to be talking about managing your security infrastructure for your cloud-delivered firewalls using Terraform. My name is Sidhu Warrior. I'm a principal engineer at Cisco. I have another slide talking about myself, so I'll talk a little bit more about what I do when I get to that slide, because I'm kind of excited about that slide. So there is a WebEx space for this room. I'd be more than happy to take questions and answer them. So it's me and my team that have worked on this Terraform API, this Terraform provider. And yeah, we're really excited to get your feedback, and we'll try our best to be as responsive as we can about issues. Oh, and by the way, the Terraform provider that I'm going to be talking about today, I'm going to be talking about two. I own the security cloud control Terraform provider, and it's completely open source. Both of them are open source, and we welcome pull requests if you guys like writing Go. Right, who am I? I'm clearly an Arsenal fan. I am not having a good season, for those of you who follow football. We just keep having too many injuries. I am part of the security business unit, and I'm the principal engineer for the cloud-delivered firewall on security cloud control. Prior to this, I was the principal engineer for Cisco Defense Orchestrator. I've been at Cisco for about 11 years, starting out with an acquisition called ScanSafe. Those of you who've used Cisco for a very long time might remember that. And then I went on to be part of the founding team of Cisco Defense Orchestrator. I like it here, and well, that's why I'm still here. I get to come to awesome places like Melbourne. What am I responsible for? I am responsible for APIs and automation for security cloud controls, cloud-delivered firewall. So essentially, with a specific focus on managed security service providers. What I'm trying to do is make it easy for enterprises and managed service providers to manage our products without having to use the UI. I don't like UIs. I can't write TypeScript to save my life. So what I really do like writing code in is primarily Java, but I also, I know it's not very fashionable, but also Go. Other than that, I like cricket. If there's any Australians in the room here today, sorry guys. Next year we're going to take the Ashes back. You've had it for too long. And I think, India coming soon, right? Yeah. So there's a couple of places, a couple of times over the next few months that I'm not going to be rooting for you. And as I've already mentioned, I support Arsenal FC. I do have more to talk about than cricket and football, so let's get started. So a question that, how many of you have used Cisco Defense Orchestrator? I see a few hands up here. And so you guys probably heard a lot about security cloud control this week. So what is security cloud control? Security cloud control is the future of Cisco security. So why are we doing this? We've spoken to our customers, and what we understood is that 75% of our customers are pursuing vendor consolidation. They want to bring in, manage all aspects of their security using a single vendor. And historically, we haven't made it easy because you have divergent management platforms. And so that is why we are releasing Security Cloud Control. It's centralized security management as of now for Cisco firewalls, that's ASAs and our next generation firewalls, the FTDs. Multi-cloud defense. Multi-cloud defense is a way to provide security to your hybrid cloud environments. We work across a range of public clouds. And how many of you guys have heard of Hypershield? Cool, so Hypershield is part of Security Cloud Control today. And Hypershield is really cool in that it takes the firewalling to where your compute is using eBPFs. And Cisco Security Cloud Control is available down under now. It's as of last April. We released it in Australia. So os.manage.security.cisco.com/new. You can go there and get yourself a Security Cloud Control account, a tenant, and try out all the things that we're talking about here. I'll be talking about here today. Right. So the easiest way to explain how our Terraform provider works is to try and tell it to you as a story by solving a specific use case. So I'm going to be talking about the managed security service provider use case. A lot of this use case was, we defined it in partnership with MSSPs in Australia, and some of them are in the room. Hello there. And so a lot of what I'm going to be talking about has come from talking to customers and working with them. So what does an MSSP need? And by the way, while I will be focusing on the MSSP use case, I think a lot of this does apply to other use cases as well. The reason I'm picking one use case is because it's easier to work through the whole thing using a concrete example. So what does an MSSP need to do? The first thing they need to do is when a customer comes in, they want to kick it. They need to get them set up as soon as possible so that they can start charging them and making revenue. What's the second thing the MSP needs to do? Once they've got the customer set up, they need to get the customer's security infrastructure up. The security infrastructure is only the first step, typically, because you're not just providing them with the security infrastructure, you need to get their applications up behind the security infrastructure. So we want to make it as easy as possible to get that first step out of the way. Then, obviously, you want to be able to monitor it. So if something does go wrong, you want to know proactively so that you hit your SLAs. If you don't hit your SLAs, obviously you've got a penalty. So what we want to do is make it easy for you to perform monitoring proactively. Now, this is not something that we can do with the Terraform provider. We provide APIs for it, but I'm just calling it out here. And then finally, of course, you want to be able to upgrade your firewalls. If there is a CVE, new vulnerabilities come up every day, we want to make it really easy for you to upgrade your firewalls so that you always stay on top of CVEs. I'm going to be focusing on this talk primarily on the first two balls here. Kicking it, getting a new customer set up, and provisioning it, getting your security infrastructure stood up and managed with a baseline policy. So, and I'm going to be doing that using infrastructure as code with Terraform. Quick show of hands here before I go further. I just want to gauge to understand how many of you guys use Terraform on a regular basis? So that's a few people in the room. How many of you have come across Terraform? How familiar, you're reasonably familiar with how Terraform works? Cool, so what I will do is, I think about half the room is reasonably familiar with Terraform, so I'll take a little bit of time to talk about some basic concepts of Terraform. My apologies to those of you who do Terraform day in, day out, so this is stuff that you probably already know. But let's start off by talking about what infrastructure as code is. Infrastructure as code is something I'm very passionate about. Security Cloud Control is entirely deployed in the public cloud, and we could not do it without infrastructure as code. As far as we are concerned, if any component of our infrastructure is not defined in Terraform, it does not exist. And so what we do is we define every single component of our infrastructure, be it a server, be it an access rule, be it a routing table, in code. There are many different IAC platforms you can use. The two big ones are Terraform and Ansible. So personally, the way I look at it, and this is purely my own this is purely my own judgment, is that Terraform is something I would use to define infrastructure above the operating system level, and I prefer to use Ansible if I am actually provisioning something inside the operating system. So if I want to make sure that a particular template has all the right applications, I will use Ansible. If I want to make sure that I've got a cluster of 4 VMs behind a load balancer, I'm going to be using Terraform. And the cool thing about infrastructure as code is that you can define it to target a variety of different platforms. You can write the same code, more or less. Your results may vary, and use it pretty much to apply across different vendors. So you could apply across AWS and VMware, for instance. And you can definitely do. You can apply across different regions. So for instance, Security Cloud Control is deployed in 5 regions globally. There is no way we could stand all. We have over 100 microservices. We have something like 200 or 300 Lambdas. We have incredibly complex VPCs and security groups and routing between our components, there is no way we could deploy it across 5 regions consistently if it weren't for infrastructure as code. And that is why, being such a proponent of infrastructure as code in the way we do our own thing, we want to make it easy for you as our customers to start using it with our products as well. So many, many years ago, I don't know if you guys remember that famous Microsoft Loves Linux talk that, Steve Ballmer gave? And ever since then, I've always wanted to do something similar. And so this slide exists purely so that I can say that's, just so that I could use a heart emoji in presentation. So what we have done is we built a Terraform plugin to manage security cloud control. So let's talk about some basic concepts of Terraform. So what is a Terraform provider? A Terraform provider is a plugin that essentially provides you with the ability to interact with a particular service. So for example, here, we've got a vSphere provider that allows you to interact with VMware. You can use it to spin up VMware instances, VMs. You can use it to create templates and so on. Over there, we've got the AWS provider, which we use a fair bit internally. This is what we use to interact with any kind of AWS resource, be it EC2 instances, ECS Fargate clusters, EKS Kubernetes clusters, whatever. And then on top are our own Terraform providers. The security cloud control provider, it's still called CDO at the moment. We will be renaming it to SCC. However, that does not mean that this will stop working. This will continue to work. When we release the SCC provider, all that's going to happen is newer features will go there, and we will provide a migration guide. And we've got the FMC provider, which allows you to manage the Firewall Management Center. The FMC provider allows you to define things like access policies, access rules, IPS policies, and so on. And that's what a Terraform provider is. So when you want to define your infrastructure using Terraform, there are 2 basic concepts you need to understand. A resource, that first one is a resource. A resource is a component of your Terraform managed infrastructure. So here I've got 4 different examples of resources. On the top left is how you would define a Cisco secure firewall on your security cloud control tenant using the security cloud control provider. On the bottom right is another example of how you would define a virtual machine in vSphere. The point is a resource can be anything. It can be an instance, it can be a policy, it can be a representation of a security device. What a resource is really depends on how the provider developer decides to define a resource. However, sometimes some components of your infrastructure have already been created. You've gone and created a VM in vSphere already. You've spun up a couple of EC2 instances. You've got a security cloud control tenant spun up already, but you need to use it in your Terraform. How do you do that? A data source gives you a read-only view into components defined elsewhere so that you can use it in order to define the rest of your Terraform. To give you an example, let's take the data CDO tenant current. So I'm essentially fetching the security cloud control tenant that I'm authenticated to, and then I can use that to, say, for instance, create users. So I did live, and I said there's 2 concepts. There's a 3rd concept that I'm going to introduce you to, a Terraform module. So a Terraform module is essentially a collection of configuration files. A Terraform configuration files are where you specify your resources, data sources, and so on. You can collect them all into a single directory so that you can reuse them. So, for example, this is a great way to encapsulate your Terraform code so that you can keep it dry. Do not repeat yourself. It can be downloaded from GitHub. For instance, over here is a Terraform module that we use to spin up our secure device connectors on AWS. We've published it to GitHub. On top is actually something from our own internal Terraform code. We defined a module to do some stuff with the FMC, and it's basically in the directory, in the parent directory, in a subdirectory of a parent directory called module/FMC. And then we can use this multiple times. We can just change the parameters and so on. It's a bit like a function call. So how do you get started with the security cloud control Terraform provider. Now, we're going to be talking about it from an MSSP use case to how an MSSP can go and spin up a new customer. So the first thing you need is an MSSP portal. An MSSP portal gives you a bird's eye view across your entire infrastructure. You can use it if you're an MSSP. You can also use it if you're an enterprise with large numbers of different branches. Say, for instance, you have a bunch of firewalls in a data center in Sydney, and then you've got a bunch in Perth. You might want to keep them completely separate in different tenants, but then you want to have an overarching view. So you can spin up security cloud control tenants by yourself, but not everybody needs an MSSP portal, and so we ask that you contact your sales team or TAC to get an MSSP portal. And then once you have an MSSP portal, you want to generate an API token. We use this API token for the Terraform provider to authenticate itself with security cloud control. Let's see what that looks like. You just go in. This is pretty much the only stuff that we're going to be doing in the UI in the stock. So you go in, you log in, go to settings, user management, and we recommend that you create a special kind of user called an API-only user. An API-only user cannot log into, say, security cloud control using the web browser, and it is not tied to any given identity in your organization. So that means if you write a whole bunch of automation and you leave, it doesn't stop working when you leave. Though, of course, you've left, so you may not care that much about it. So you can copy the API token, and then you're going to use the API token in our Terraform provider. How do we do that? So what we're going to do is we're going to define a couple of variables to be able to connect to security cloud control. There's two variables that we need in order to connect to security cloud control. The first one is a base URL, which is the URL that you access security cloud control from. So if you're in Australia, that's aus.manage.security.cisco.com. The second one is the API token that you generated. So this file is called a variables file in Terraform. This is where you define what your Terraform configuration needs in order to be able to be used. So the variables can be fetched from environment variables as well, or you can define them in a file called a tfvas file. So I'm going to modify the tfvas file and add in a base URL and an API token. That is obviously not a real API token. Our API tokens are JWT tokens. And then we're going to create a providers file where we tell Terraform, hey, this is the provider that we are going to use, the CDO provider. And it's called the CDO provider, but the security cloud control provider. And then you provide two parameters that we need, the base URL, I'm in Australia, and the API token. And you're good to go. So now what we're going to do is we are going to define a reusable module. Why are we going to do that? So typically, for an MSSP, you're going to have pretty similar configuration across your tenants. Otherwise, you're spending a lot of effort managing your tenants separately. So you're going to define the new tenant's configuration once. You're going to parameterize it so that we can make small changes for each customer, and then you can use it multiple times. Now, how do we do it? Well, the first thing we want to do, a module is essentially a directory. We're going to create a directory here, and we are going to call it MSSP customer, modules/MSSP customer. It doesn't have to be in a directory called modules, it's just a convention. And then what you're going to do is we're going to define the required variables in order to be able to spin up a new security cloud control tenant. We need the name of the tenant, so we know what we're going to create. We want a display name. That's what's going to show up in the UI when your engineers or the customer logs in. And you want to specify a list of users. So each user has a username, a role, and a flag indicating whether it's an API-only user. And we are going to put it inside a variables.tf file. You can call it whatever you want, but there's some conventions in Terraform. You typically put your variables in a file called variables.tf. Also, I can't seem to say variables this morning. Now, in the main Terraform configuration, we're going to create two tenants, and Bumera and Virajiri, I should have chosen names that I can't pronounce correctly, so apologies if I'm mispronouncing it. And we also want to define a list of users for the MSSP, so your own engineers. So in every single tenant, what you want to do is you want to make sure that your own engineers have super admin access, and you want to provide read-only access to some of your customers. And so here, that's what we've done here. We've defined that's for the MSSP, that's for the first customer, that's for the second customer. And I told you how we can use modules to reuse the same code. I'm going to be onboarding 2 customers here. The first we're using the same code. The first module is for Woomera Enterprises, and I'm going to call it Woomera Enterprises. And here, if you notice, what I've done is the list of users is going to be the users we defined from Woomera.com and the MSSP engineers. And the second one, we're doing pretty much the same thing, but you notice the tenant name is different, the display name is different, and the users are different in that the MSSP users are still there. However, we're bringing in a separate set of users. Cool. We're now ready to actually do the first bit where we create a customer's tenant. And for that, we are going to be using this resource called the MSP managed tenant. It takes 2 parameters. It takes a name and a display name. A display name is optional. And the reason this is on, so our Terraform provider is accessible on registry.terraform.io. Just go in and search for CDO and you find it. I will be sharing these slides on the WebEx space, so you'll have access to all these links. I'll also be sharing the code that I wrote that I'm showing you through this talk, so you can. It's also completely open source. Feel free to fork it and improve it if you would like to. So let's create a new file called 01tenants.tf. So what's this 01 business? Just a small sidebar. So Terraform uses a dependency graph to figure out what to apply first. So if there's a resource A that depends on a resource B because you're using an output of resource A, it'll apply resource A first and then resource B. But if there are no dependencies, it will always go in alphabetical order. So in earlier versions of Terraform, it did not do any dependency. This is like going back years. It did not do any dependency graph calculations. And so the convention of naming your Terraform file 01, 02, and so on dates back to the old days. I'm old, so, you know, I keep doing some of these things. So we're going to define a resource called CDO MSP managed tenant, specify the name and display name. 3 lines of code, 4 counting the braces. And then we're going to apply the Terraform. So the way Terraform works is it's stateful. It checks the current state of your infrastructure, it checks the current state of your configuration, finds the difference, and applies the difference. Let's take a look at how that goes. So the first thing we're doing is a Terraform init, which is to download all the plugins. We are going to be using the CDO plugin, so we downloaded that. And then we're going to run Terraform apply. And we're going to create 2 tenants. This is going to take a few seconds. Oh, the first tenant's already created, the Woomera one, and the second one is now created. Cool. So we've created the customer's tenant. Now we need to add users. We have a resource for that too, MSP managed tenant users. It takes 2 parameters. The unique identifier of the tenant that we created. Every tenant, every object in Security Cloud Control has a unique identifier, and that is a UUID, a universally unique identifier. And we're now going to define a list of users. The list of users, the schema is it takes a username, a role, and whether it's an API-only user. Just remind you, an API-only user is the thing I talked to you about, where a user that you use for automation. So how do we go about defining this? Again, it's super simple. We just created the tenant, and so we are going to get the ID parameter of the tenant and use that in the tenant UID argument. And we're going to pass in the list of users, which we passed in as a variable, into the users parameter. And how do we go about applying it? Terraform apply. That's it. When you do Terraform apply, it's going to look at what you've already got. We've already created the tenants, so it doesn't need to apply that. It notices that we only need to add the users, so it says 2 to add, 0 to change, 0 to destroy. Sweet. Okay, a few of you we'll have the question, hey, what's your support for federated identity providers? We do support federated identity providers in security cloud control, which means you do not need to use Cisco single sign-on to use your security cloud control tenant. We do not yet have a Terraform resource for federated IDPs, but we're working on this, and it should be coming fairly soon. Depending on how tired I feel, I might even be writing the code for it tomorrow. So let's go on to the next bit. We've created the user, we created the tenant, we created the users. Now we want to actually be able to perform operations on the newly created tenant. And for that, we need a token for the newly created tenant. So how do we go about doing that? We are going to use a resource called the MSP Managed Tenant User API Token. So you're going to specify the UID of a user in the newly created tenant and the UID of the tenant, and then you can get an API token for the newly created tenant so you can perform operations on that tenant. So we're going to define a file called 03token.tf, and the resource is going to be called MSP Managed Tenant User API Token, and it's got these two values. And we want to return this value to the main Terraform configuration. And the way we're going to do that is using a Terraform concept called an output. So an output is, as you guess, output. So you can basically return some value from your module and use it somewhere else. And the output is going to be the value of the API token that we just created. You'll notice that there's something called sensitive is equal to true. If you do not set this, it'll print the API token into the terminal, and you don't want that. And so if you're ever printing out sensitive information, make sure sensitive is set to true. If you're ever outputting sensitive information. So again, applying the Terraform is the same as before. I'm not going to bore you with that. And I'm going to go on to doing the next step. We've got the managed tenant. We need a cloud-delivered firewall management center in the managed tenant in order to be able to create a baseline policy that we want to apply to all of our customers. And so if we want to change that baseline policy, we make the change once. It applies across 100 customers, 100 branches, whatever. So we're actually going to create a new module for this. It's going to be called MSSP Tenant Resources. And we're going to be we want to use the security cloud control provider, but with different credentials. How do you go about doing that? You go about doing that using aliases, which is, in my opinion, the coolest Terraform feature. You'll see that in a second. And then we're going to import the new module into the main configuration. And finally, we're going to provision the cloud-delivered FMC. So how do we use the aliased CDO provider in the new module? So it's this bit there. I'm going to hop down here. Alias. So what we're saying is that we're defining another instance of the security cloud control provider, but we're using a different token. So, and then, we want to create the CDO CDFMC, we want to create the CDFMC resource. And the resource is called CDFMC. This is how you define it. There's nothing to do here except to say, I want you to create the CDFMC in the managed tenant, not in the MSP portal. So all you need to specify is this line which says provider is equal to the alias name. So then you want to add the new modules to the main Terraform config. So we're going to call it Woomera Enterprises Resources, Wiradjuri Network Resources. It takes two parameters, the base URL and the API token returned by our first module, which is pretty cool. Well, if you're a nerd, it's cool. And then let's go ahead and apply our Terraform. So what it's going to do now is it's going to create two cloud-delivered FMCs that you can use to manage your firewall policies. This takes a while, between 15 and 30 minutes. And while that happens, no, I'm not going to make you wait for 15 or 30 minutes. I've got a nice animation. At least I believe I do. Maybe I am making you wait too long. Let's go. Yes, there we go. About 15 minutes later, It's all done. So now we've got a cloud-delivered FMC, we can actually start defining our default policies. How are we going to do it? So we're going to configure the FMC Terraform provider. We've got a second provider coming in. Technically a third, because we've got two of our security cloud control providers. We're going to create an access policy using the FMC access policies resource, and then we're going to create an access rule to block a bunch of gambling websites using FMC access rules. So a lot of people treat our next generation firewall as an IP firewall with IPS. But some of the cool things that you get with it are like threat intelligence feeds from Talos. So Talos will tell you which URLs belong to the gambling category and so on. So this is pretty cool, in my opinion. So we've defined the CDFMC resource, and now we're going to define the FMC resource, which is going to take as a host name, you provide the host name of the CDFMC. That's returned as an output from the other resource. You need to say that it's a CDFMC. You need to pass in the token for the managed tenant. And how many of you guys are FMC users, by the way, over here? Yeah, I think there's a few here. So FMC has the concept of domains, as you know. A cloud-delivered FMC currently has a single domain. What we do to provide multi-domain is to use security cloud control tenants. So you just need to specify the domain UID of the CDFMC. Now let's look at the FMC access policies resource. Fairly straightforward. Give it a name, specify the default action. You can do a bunch of other things, but you can read up about it in the documentation on registry.terraform.io. I'm going to do a basic policy. I'm going to say, I'm going to create a policy called MSP access policy, the default actions block. And over here, what you can see is me explicitly defining something in the dependency graph, saying, I do not want you to create this access policy until the FMC is ready. It's strictly not necessary, but I just put it in to show you guys how you can explicitly define dependencies between your resources. Now we're going to define an access rule. The access rule, you can do a whole bunch of things, but what we're going to do is fairly straightforward. We are going to say, I want you to block gambling websites for any IPs, so from any IPs in your network to the URLs which are in the object group gambling. Then you just apply the Terraform as per normal. So when you run Terraform apply, what you're going to see is that we're going to be creating an access policy in each CDFMC for each customer. So now you can see that since we're doing it for both customers, if you make a change now to your access rule, that's going to apply across both your customers, across all hundreds of your customers, hundreds of your tenants. And what does that look like in security cloud control? You just have a rule that says it's blocking gambling. All right, the meat of the presentation. You want to get your secure firewalls onboarded into security cloud control across all your customers. So what we are going to do is, there's two ways you can do it. We provide a Meraki-like zero-touch provisioning experience. I'm not going to be talking about that here. But we don't support zero-touch provisioning for all of our hardware. We don't support it for our virtual hardware, for instance, because it requires a serial number. So what you can do then is you generate a configure manager CLI. A configure manager CLI tells Cisco Secure Firewall that your firewall is now, that it's going to be managed by an FMC. And you tell it which FMC to use. And then what we're going to do is, what you typically would do is you'd go into the FTD using SSH or RS-232 and paste the configure manager CLI in. What I'm going to show you here is how you can use Terraform to do the SSHing in for you. So it's a Lukma, no hands kind of thing. And then finally, you need to tell the FTD that it needs to register to security cloud control. And we're going to do this all without any human intervention. The first resource we're going to use is the FTD device resource. It takes just 4 parameters. 5 maybe. Yeah, 5. It takes a name. It takes the name of the access policy that you want to apply. So we've already created an access policy, a baseline access policy we want to apply to all of our tenants. You need to specify a list of licenses that you purchased. and then you need to indicate whether it's a virtual FTD or a physical FTD. If it's a virtual FTD, there is another parameter you need to specify called the performance tier. And what I'm doing here is I am creating multiple FTD resources. So Terraform has the ability to execute loops. So what you're seeing here is on the second line, it says count is equal to length of var.ftds. We're taking a variable parameter which defines a list of FTDs, and then we're going to loop through each one of those and create a record in Security Cloud Control. You can have 1, you can have 2, you can have 10, because each customer is different, each tenant is different. And then you're specifying the licenses, the name, whether it's virtual, and you can do some pretty cool conditional logic as well. So if the firewall is virtual, then add the performance tier, otherwise just return null. And once that is created, we'll have a configure manager CLI. So for each of the FTDs, again, instead of defining it multiple times, and we can also have like multiple, we can have different numbers of FTDs for each of our tenants. We are going to SSA, we're going to use something called a local exec provisioner inside a null resource. These things are really cool, by the way. Reading about null resource, they don't recommend you use it for most cases because there's usually a better solution. But for this, there isn't a better solution, so it does come in handy. You're going to define a local exec provisioner, and all the local exec provisioner is doing is it's SSHing into the FTD and pasting the generated command over here. So the generated command is an output of the FTD device resource. And then, at this point, the FTD knows it's got to register with this particular cloud-delivered FMC on Security Cloud Control. We will use this resource called FTD device onboarding to complete the registration of the FTD to Security Cloud Control and its cloud-delivered FMC. And that's pretty straightforward. Again, you notice that there's a count argument. That's a Terraform loop. If you guys don't use the count argument and are writing a lot of Terraform, do look at it. It is incredibly handy. Count and for each will change your life. And then you need to specify the UID of the FTD. And again, we need to do it for every single FTD. And you notice the dependency graph being defined again. I don't want to start the registration process until after I have pasted the configure manager CLI. So if you notice, when I'm applying Terraform, I've got a Terraform init as well this time. The last several times we just did Terraform apply. There's a couple of reasons for this. We've defined a new provider here, the null resource provider. So you need to install that. Let's see how this goes. I'm not showing you the video of Terraform init. You've already seen that, so I cut that out. I'm creating so what it's going to do is it's going to generate the configure manager CLIs for each of the FTDs. It's going to paste SSH into those FTDs, paste the configure manager CLI, and that's all done in like 14 seconds. And then we start the registration process. The registration process takes a while. And the reason the registration process takes a while is because it's not quite so straightforward. I'll come to that in a second because I want to show you what it looks like on Security Cloud Control. So when you log into your MSP portal, sorry, when I recorded this video, I was on a really bad internet connection. So there's a lot of me waiting around here. And if you go to tenants, you can see that we've got 2 tenants now. Registry Networks and Vimera Enterprises. And if you went to security devices, you'd see the devices from both tenants. So let's go into one of them and click through the security devices. And you can see that we've created a device called Uluru in Virajiri Networks. And if you go and take a look at the overview of the device, we'll be able to see that it's a virtual FTD. And you can see all kinds of information like its threat defense and what a performance tier it's using. And you can see that the MSP access policy that we defined, the one that blocks gambling, is targeting one device. And now let's look at the other tenants. So we're just going to go back to the MSP portal here and select the other tenant. And this is where the MSP portal really comes to the fore. Even if you're not an MSP, if you have multiple tenants, it's a great way to see your devices across all of them. By the way, apologies for some of the tenant names. This is my own MSP portal. I just create random tenants all the time when I'm testing stuff out. And if you take a look here, we've got a completely different device. It's called Wagga Wagga. And let's go to the, let's go and take a look at the access policies. You can see it's got the MSP access policy. It's targeting one device and it's got gambling blocked. So I just want to come back to what I was saying earlier about why the registration takes a long time. The registration is not just the FTD letting Security Cloud Control know it's there. Security Cloud Control then pushes the access policy that you define onto the FTD, deploys it, so your FTD is ready to go. So at this point, once you run that Terraform, in about 5 minutes, you have gone from 0 to actually having an FTD doing the actual firewalling. And that is pretty much it. I've got about 3 minutes spare still. Thank you guys for turning up on a Friday morning and listening to me prattle on. Clearly, as you can see, I quite like this stuff. Please complete your session evaluations. My boss owns a bullwhip. When I get bad session evaluations, I get locked up in a room and whipped. No, I'm making it up. My boss is lovely. And I'll be sharing these slides on the WebEx space. I'll also share the code that I showed you. It's all on my personal GitHub. And thank you very much for coming in.